Have you ever wondered how Netflix predicts what you'll watch? Or how AI somehow learns from its mistakes? Here's the truth. Your model doesn't magically know the answer. It stumbles, it guesses, it adjusts, over and over again. And behind all of that, one deceptively simple idea: gradient descent. Today, I'm going to break down the hidden math that teaches AI how to improve itself, without turning this into a calculus lecture. By the end of this video, you'll understand what a loss function actually is, why models don't instantly find the right answer, and how gradient descent slowly, almost stubbornly, finds the best solution. Let's make this simple. Imagine you're standing on a foggy mountain. You can't see the bottom. You don't know where the lowest point is. But your goal is simple: get downhill. That mountain, it's your loss function. A loss function is just a fancy way of saying, how wrong is my model right now? If the model's predictions are bad, you're high up on the mountain. If predictions are good, you're closer to the bottom. The lowest point on that mountain. That's the best possible model, the smallest error. But here's the problem. There's no elevator, no map, no shortcut. So what do? You feel the slope beneath your feet. And take a small step downhill. That step, that's gradient descent. Now let's zoom in. Your model has parameters, little adjustable knobs. In math, we call them theta. These parameters control how your model behaves. At first, they're random, which means your predictions are random. Gradient descent looks at the slope of the loss function, basically asking, if I tweak this parameter slightly, will error go up or down? If the slope says error increases, it moves the other way. If the slope says error decreases, it keeps going. Tiny step, recalculate, tiny step, recalculate, over and over. It's not solving the equation in one shot. It's approaching the answer. And this is where beginners get confused. They expect the model to just know the right answer. But machine learning isn't magic. It's controlled trial and error. But here's the catch. If your steps are too big, you might overshoot the valley entirely. If your steps are too small, you'll crawl downhill painfully slow. That step size has a name: learning rate. The learning rate controls how aggressively the model updates itself. Too high, it explodes and never settles. Too low, it takes forever to learn. This is why training sometimes fails to converge. It's not broken, it's just stepping wrong. And this right here, adjusting the learning rate, is what separates beginners from real data scientists. Now let's talk about something subtle. Gradient descent doesn't see the whole mountain. It only sees the slope where it's currently standing. What if there's a small dip nearby, but not the lowest point? It might settle in the wrong place. That's called a local minimum. And yes, this is why training deep learning models can be unpredictable. The algorithm is blindly following slopes. Smart, but still blind. So why does this matter? Because every powerful model you hear about, neural networks, recommendation systems, self-driving car perception, they all rely on some version of gradient descent. Without it, models wouldn't improve. They'd just sit there. Wrong. Forever. Gradient descent is what turns guessing into learning. It transforms randomness into optimization. And here's the deeper insight. The real skill isn't just coding gradient descent. It's understanding why it works. Because when your model refuses to improve, when loss won't go down, when accuracy plateaus, you'll know where to look. Learning rate, data scaling, initialization, optimization settings. That's when you stop being someone who runs models and start being someone who understands them. So let's recap. A loss function measures how wrong your model is. Gradient descent finds the downhill direction. The learning rate controls step size, and tiny repeated improvements lead to powerful results. It's not flashy, it's not glamorous, but it's the quiet engine behind modern AI. And now, you understand it. If this finally made gradient descent click for you, hit subscribe for more beginner-friendly breakdowns of complex AI concepts. Because the math behind machine learning, it's only scary until someone explains the mountain.